All right, people, come on. Let's start. Shh. 8B50, let's start here. All right. Does anyone want me to open the curtains, to draw the curtains? No? You sure? No? All right, come down. Need you to need you to have your book out, Murat. Books out. All right, boys at the back, make sure your books are out. Isabel and also Xavier. Okay. Xavier, is it? Okay. All right. We're going to start, and I'm recording. Come on. So, the other day we spoke so much about igneous. We talked so much about igneous because you are actually being introduced into the rocks. Now we are talking about sedimentary and metamorphic. All right, you've seen this slide. I'm not going to talk more about it. As usual, if you see these two, you know what to do. But of course, you won't see the homework section yet because your homework is not here. I'm going to derive your homework from somewhere else. So, we know about sedimentary rocks, and this is just the starting point. Does everyone know what this particular picture here is? Yes, the Grand Canyon, sedimentary rocks and Grand Canyon. One of the major characteristics, guys, can you actually see all this layering of sediments? All right, you can see all the beautiful sediments, and this is a perfect example of sedimentary rocks. Remember back in our igneous section when we were talking about weathering, okay? So weathering here, due to the fact that we have a bit of erosion and you know all the deposits that we talked about, we talk about those erosions, and those erosions here are basically about deposits, all right? So this here, after many, many years, we talk about billions. We're not talking about millions, we're talking about billions. All right, so these layers are actually formed bit by bit, and this is an amazing, spectacular sight because this is what you can see, what the earth has actually done towards the rocks. All right, so this is the Grand Canyon indeed, what you have seen so far. Now, guys, sorry, but could you guys please pay attention? What we are looking into this case here now is this. How are these sedimentary rocks formed? All right, so we are going to take it from the top. First point says that it is formed from sediments, which just makes sense, doesn't it? Because the word sedimentary does derive from the word sediment. All right, I'm just giving you the definition after that. Loose rock particles due to weathering and also erosion. It's up to you whether you want to take this explanation because you don't have to repeat it. All you need to do here is just remember that sedimentary rocks are actually formed from what? From sediments themselves. All right, but if the question requires you to elaborate, all you need to do is just to think, all right, sediments are actually, tiny rock particles. And okay, they actually deposit, they actually layer, the rocks bit by bit. And it's due to what? Weathering and erosion. Because without weathering and erosion, without these two factors, you will not be able to get the rocks themselves. All right, so this is the important section here, formed from sediments. Right? I won't take any further than that. You have to talk about weathering and erosion. It's a whole big connection. What sort of weathering have we seen in our previous topic? Does anyone remember? Hands up those who know. What sort of weathering we have seen before? Yes? Now, erosion is a different type of a factor. I'm talking an example of a weathering. Yes? The wind is an example. All right, that is a physical example. Yes? Water as well. Yes? Yes, temperature change as well. So these are all physical factors. All right, guys, physical factors. Whereas erosion here is actually being carried down by the water from the top of the mountain to the bottom, for example. And it is this water that carries down the erosion, that carries down the soil and all those tiny little particles that are seen. Okay, so this is basically the whole part of the idea. And of course, right, sedimentary rocks are formed due to these factors: sediment, cement, pressure, evaporation, and crystallization. All right, these are some of the factors. All right, some of the factors which will contribute towards the formation of sedimentary rocks. And why is it that in this particular section here we have so many factors that contribute towards sedimentary rocks? Yes, sorry. No, no, Cameron is not in this class. Yeah. No, no. No, no, not in this class. All right, thanks. No worries. Which one? The second point or the last three? Well, as I said, you don't have to copy word by word. You take out the important points because this is the strength of note taking. You don't have to write exactly like me. You just have to understand what I'm trying to say. And that is the strength of note taking, because this art is a lost art. All right. So I'm trying to train some of you guys. If in case a future teacher were to use it, or you want to go out, study, continuing in tertiary education, for example, this is how they will present the material. Right. And it is up to you how you want to extract them. Okay. Anyway, such factors as this, as I've mentioned, sorry for the interruption just now, 1, 2, 3, 4, 5, these are some of the factors, all right? Because these factors here need to ensure that you have these igneous rocks, being, shot up from the volcano, for example, into the earth, making sure that, sedimentary rocks are formed from weathering and erosion. Yes? Very good question here, because this is what we're going to come into. Now, there are three types of sedimentary rocks being formed. One is known as clastic, the second is known as chemical, the third one is known as organic. And as what you have asked, in terms of the decaying of organisms, in terms of fossil, we will normally get it in the organic section here, because this is related with dead animals or plants. All right? So whatever that we have, remember, guys, the elements in nature needs to recycle. You need to have a constant cycle, to recycle those rocks. You got to remember that everything is always a cycle. You break the cycle, you break what happens in nature itself. Okay? Now, that was organic. Now, in terms of chemical, think about it. You need to think about crystallization. That is why one of the factors mentioned here is crystallization. Crystallization here is the formation of crystals. It's simple as that. Think about it. I have to teach you guys English. Crystallization. Think about the last spelling, Asian. It's just like action, isn't it? So you have to think of it as a process. It is a verb. No, it's not a verb. Classificate. No. Crystallization. No, it's a process. It's not a verb. You're definitely right. But crystallizing is a verb, all right? I'm not going to teach you English anyway. That's chemical for you. Right? In chemical rocks as well, you will also tend to find fossils. So these two here will overlap, and the two most difficult rocks for you to distinguish is actually the chemical and the organic rocks here. Okay? Now, clastic is one of the very popular sedimentary rocks because they are formed from pieces of weathered rock. All right? Bless you. All right? Just make sure of that these are your three components that you need to know. You don't have to copy it sentence by sentence. God bless you. All right? Everyone okay with this slide here? All right? Okay. Nope. I'll give you some time. But anyway, guys, this is how we classify sedimentary rocks. Previously, let's try to retract. How many types of igneous rocks have we learned so far? Yes?
The
Intrusive and extrusive. Brilliant. Fantastic. Okay. What about the definition of an intrusive rock? How do you define it? Yes.
the rocks that are
Form inside the magma, form inside the lava. And what about extrusive? I know you were trying to get me. Yeah, you.
which are formed outside.
Form outside as soon as it's shot up from the volcano itself. All right. Now, boys at the back there, I hope that you can also participate. You're not just there as a passive listener. You have to be a proactive listener and also a speaker at the same time. Okay. Everyone done with this? Okay, next one. Now, these are your classic sedimentary rocks. We will touch on the first one. General characteristics. These are the first 3 points. As you can see, benchmark it with the pictures over here. Why do I include pictures? Because pictures say 1,000 words and you can see it much better. All right. So our first general characteristic is simple. When you saw the Grand Canyons earlier on, you have seen layering. So the first general characteristic here is layers. And what do these layers here actually mean from one another? It is actually the sediments. Aha! Have we seen sediments here, the term here before? Can anyone here give me what the definition of this sediments here mean? Anyone here? At the back? Sediments. What are sediments?
The lines on the rocks. And then like, what do they call it? Something like
The-
sediment.
It's what?
Little bits of
Little bits of? Yes, 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 you're getting it.
rocks and bits of like.
Bits of rocks, all right? You have particles of rocks. Good to those who put their hands up. I'm trying to give the others as well a chance to actually answer, right? Loose particles. Sediments here are loose particles, rock particles. Because you're studying about rocks, there's nothing else but rocks, all right? So loose rock particles, that's the definition of it. And they build on top one another. We will see how this deposition will actually occur. Okay? Second point that we have here is that the grains do not interlock. Put it this way. When you had seen the igneous rocks, especially the granite and also the granodiorite, have you actually seen those crystals interlocking with each other? What I meant by interlocking is this. On the board, if you can see, all right, this is the size of your crystals. This is the crystals being formed. Everything is interlocked. Okay, so it's just basically a cluster. This is what we mean by an interlocking grain, crystal grains. All right, they are all sort of like arranged in squares and all on top of one another. Whereas for the sedimentary rocks, they do not interlock. All right, and why do they not interlock here? Let's have a look. Let's just say this is our rock, right? And we know that sediments are loose rock particles. The rock particles that you see would just definitely be separated from one another. But question here, guys, why are these not interlocked? That is because in the middle here, we have what we call natural cement. All right, the natural cement here would definitely be, the mud, for example, clay. All right, these are all natural resources of cements. So I'll just put here as a natural cement. And of course, you definitely know natural cement would definitely take into consideration the clay, the mud, and other stones and pebbles whatsoever. And that is why, if we see here, this does not actually interlock together. They're all separated. Okay? The third one. This is a may or may not statement. You may sometimes get fossils, like for example this fish here, whereby these fossils are actually dead organisms, all right? The dead organisms, they actually sink into the sediments. They are covered by the water and they don't have a chance to actually, decompose into the relevant elements, for example, carbon, all right? This is all chemical and chemical base that you will see in this case here. And because of that, it will deposit or sink into the sediments, and that's why sometimes you might get fossils in sedimentary rocks, clastic ones especially. But again, as I say, whenever we label the points, these are all arranged by importance. The first one is the most important, second most important, and of course, least important. And that is when I say containing fossils, not really much. It's a may or may not. Okay? But we will see fossils more in organic and also chemical, more or less. Not so much in clastic, but not too often as well. Now, how is this formed here? You don't have to copy. You just have to listen. Imagine that this is the layer of the earth. If this is the layer of the earth, this is all your layers which have been formed. The mud, the earth, everything all collapsed together. And what happens here is that you have a lake. All right? Now, think about it. In a lake, why is it sometimes that you see it's not clear, it's not crystal clear as you expect it to be? Yes.
Because of all
That is correct. Sometimes why rivers are so dirty and polluted is because they have what we call what's that term that we saw before, you guys? Sediments. Very good. There are so much of sediments that flow in the water that to the point that it actually sinks to the bottom. So when it sinks to the bottom, due to gravity as well, do you actually notice that there is some compression? Remember, did we see the layers after layers? So when the layers go after layers and you have pressure to compress it further, that is when sedimentary rocks are actually formed. This is one of the steps for clastic ones. All right. And once the water has evaporated, after billions and millions of years, somehow the water is not be able to recycle properly, you know, it would decrease and somehow you have more sediments being formed. So as more sediments sink to the bottom here, can you see the difference between the levels of the sediments? Right? That is how one layer is formed. Layer after layer after layer. It could be the same thing. The bottom one could be mud. Second will be clay. The next one will be silt and stones. The next one will be mud again. It's a recycling. It's just recycling. It's just a recycling and repetitive, process. That's all. And once it's lost, you have cemented to form a rock. And that is how those sedimentary rocks at the back are actually formed. Okay, so this is how I explain it. Usually when I do my notes and stuff, I would do it category by category so that you can actually see what's going on here. All right, you're right there, Murad? You're right there? Next one. Examples that you can see later on. You don't have to copy this one down because there's no point remembering for the time being until you have seen the rocks themselves. You have breccia on the left hand side here. Pyrite. Now, this is something interesting about pyrite here. It is known as the fool's gold. Why is that so? Yes,
Because it looks like gold and it used to trick miners quite often.
very
Back in
good.
the day, and then they wouldn't like to split profit.
You know your stuff in rocks, fantastic. So that is why it's known as fool's gold because it looks like gold, that's one thing, but it's not real gold. It's fake. All right? So that is why pyrite is another example. Tillet, siltstone. These two are very, very important here. Okay, very important components as well. Next one, we have the shirt. All right, we have shirts at the back. We have also flints as well, but it's not here because flints are another subcategory of shirts. They may originate from the same particular rock, but they can be broken into different components. So there's a lot more that you need to learn about rocks. Conglomerate is one of the most popular examples besides Baroque. Okay? Not Baroque, Breccia. And then sandstone. Aha! This one here. This is where you can see the actual layering. The others are just choppy and rocky and rough on the surface. Sandstone is a little bit more refined, but not as refined as the marbles. Okay? Or even the quartz later that you see in metamorphic rocks. Okay? So that's the first category. Second category that we are looking into is chemical sedimentary rocks. The picture over here on the right hand side is actually a rock with shells. And what are these shells here? What's the term that we use? What was the term that we use for all these rock particles that come together? Can anyone tell me that? Rock particles. What are all these loose rock particles that sink to the bottom? What do they start with? Come on. Sediments, all right? Sedimentary is just the name of the rock. Sediments is a noun for the sedimentary rocks, okay? Sediments. Guys, these are all depositions, sediments of all, the shells in the sea, for example. General characteristics, you have crystals form, that's right. And it is actually much softer as compared to your clastic ones because clastic ones are actually formed from rocks. This one here in terms of chemical is formed from mainly chemical components, which is actually brittle. All right. The third one, this is another important point. We see sedimentary layering in clastic rocks, but we don't actually see that in chemical. All right, we don't see layering in chemical. The only way we can see and differentiate chemical is either we have the fossils here, which is the last point, but it's only a small portion. This here, you can see it is in an abundance, and the reason is because it's just being enlarged by a microscope, enlarged by a zoom camera, whatever the geologists use to take this picture. All right, it's just an enlargement. Okay. So you have learned about plastic, you have talked about chemical as well. All right, so every time when you see a category, think about the general characteristics, think about how it is formed, and some of the examples. Okay, all of you good so far? All good? Can I go to the next slide? Right. Now, how is this formed? Let's have a look here. It is the same concept and the same process as your clastic sedimentary rocks. But let's look at the first picture on the left-hand side. All right, crystals are formed and they are settled at the bottom. But as you can see, there is no sedimentary. So that is why there's no layering. So when there's no layering, you won't be able to see layers. The only thing that's happening here is that sediments will actually be deposited at the bottom. All right, and eventually when water evaporates, so when the water evaporates, what happens here is, have you heard of the word crystallization, guys? Yep. So crystallization, which is the process of what? Yes? Cross crystals being formed. That's absolutely correct. So the crystals will actually grow here. The water will be evaporated. And as a result, you will have these rocks being formed, chemical rocks, for example. Now, guys, remember in our trip to the museum, have you guys seen the halite rock? Nope. Some of you have seen, some of you have taken a picture. Yep, that's very good. Some of you have seen it. Halite is actually, guys, calm down. Halite is actually a name for sodium chloride. Guys, what is sodium chloride? Salt. It's just the normal salt that you use. All right, so the halite rocks here form is actually salt rocks. All right, and it's due to the fact that crystallization is formed. Crystals of sodium chloride is formed on the rocks. All right, and as a result, these crystals here are cemented. All right, they are cemented onto the earth or even the rocks itself. Okay, and examples that you see. Shh, shh, shh. Fossiliferous limestone. Limestone is one example, but within the limestone, you have many categories. The next one here would be halites, and as I've mentioned before, all right? So there are some more of these sedimentary chemical rocks that you will see, but more or less these two are the most important ones, okay? Now, we go to the last category, organic sedimentary rocks, all right? We have learned about clastic, we have learned about what else? Chemical, and we are down to the last one here. All right. Organic sedimentary rocks have two characteristics. They are layered, but again, it depends on the way fossils and sediments are deposited. So this here is actually a different one because organic is actually derived from dead and decaying plants and animals. All right. The one that you see on the right hand side, you can see some shells, all right, a bit of fossils in between. Usually soft, but sometimes can be hard. Okay. The one on the left hand side here is actually coal, all right, COAL. And that is how coal is used as a fossil fuel. All right? A fossil fuel that is being used as fuels. Instead of using biodiesel, we use coal in those days, but not now because coal is actually very harmful and endangering the environment as well. Very dangerous because it gives up very thick black smoke, and once you inhale it, you find that you have difficulty to cough. Not to cough. You have difficulty to breathe, not difficulty to cough. Sorry about that. You'll start coughing, but you have difficulty in breathing. All right, so these two rocks here. Okay? Everyone done with this one here? No. Okay, just wait. We'll just wait for a while. Okay, fossils and sediments. Okay, I know this is a little bit of the dull part. We still have to learn about the theory behind it, okay? But not to worry, if you need to remember, you need to recall, just go back and listen to my videos, all right? That is just a jump start. I have only these videos is because I need to support those who are absent. In case you're absent, at least you can catch up, you know what's going on, and you can feel the class environment as if you're listening at home. But I do encourage you to come to school, okay? No matter what, because we're going to have fun in class and we learn at the same time. Now, have a look here on the left hand side. We have plant materials here. Okay, you can see there are still sediments, all right, still sedimentary layers. Once this particular plant material has decomposed, what happens here is they will actually form a layer. All right, they'll be compressed together. It's also compression. And once it's compressed, these plants here will actually form coal. So as you can see, layers of sediments will actually be layered on top of it, and they compress the plant material or even an animal material. It doesn't matter what it is, all right? If it's a plant material. If it's an animal, it's an animal material. And later on, you have the layer changes that you see in the coal here. Okay? So this is how it is when it's formed with an organic sedimentary rock. Okay, now let's have a look at examples. Coal is an example, all right, but you won't be able to see coal in the laboratory here. You have to see it in, when you're doing barbecue, for example. Those charcoals that you have is actually made out of coals, but this is a raw form. The example you see here is actually a raw and a fresh form. The ones that you use for barbecuing have all been processed, all right, to make sure that you have the fuel to burn. But to be honest, flavoring this with coal is much better than the normal oil, okay, especially when you're doing barbecuing. Lovely. All right. Now that is all for the classifications and also for how it is being formed. Now let's go for the use of rocks. There are a few types that you can use. As I've mentioned, coals can be used for fossil fuels, all right? Can be used for burning, barbecuing, charcoaling, whatever it may be. Let's look at this one here on the left hand side, this round shaped thing. Does anybody know what this one is? Do you know? Sorry? Well, it is actually a little bit of sandstone because it's actually made of gypsum. All right? It's made out of gypsum. And guess what? Yes. Yes, they make yes, they do. That's right. They do put on the roofs, the ceiling rows, that's right. Or have you guys heard of plaster of Paris? This is actually plaster of Paris. And this is one of the reasons why you can use sedimentary rocks from. Okay. Now, just to ask, if this is a plaster of Paris, what sort of rock would it be? Would it be clastic? Would it be chemical? Would it be organic? Yes? Clastic? Next. Clastic? Clastic? Clastic, yes? Okay, yours? Clastic? Has anyone thought it's actually chemical? It's actually chemical. It's not clastic here. Do you know why? It's actually chemical. Do you know why? Because if you put acid onto this clastic material, no, not this plastic. If you put acid onto this chemical material, it will actually corrode because it is made up of limestone. So that is why we do not use limestone, especially in the open, because limestone can be corroded. Remember the weathering and the formation of stalactites and stalagmites that we have seen? All right, that is the reason why it is more hidden in caves rather than being the open. All right, because of the corrosion, a bit by bit, the layer by layer of corrosion will come in. So that is why we tend to avoid using limestones outside, even as by the poolside there. Okay. In the middle, what is this here? Does anybody know what this one here is? It's a rock. Yes, we know it's a rock. But some of them can actually be used for mining. This is actually iron ore. Iron ore in its raw form. You can actually extract some of these minerals. Iron is a mineral. And you can actually use it to make jewelry, for example. Or it can be even used to, make buildings, pillars of it. All right, so these are examples of it. What about this one here? Has anyone suffered from this before? Yes, before, right? Not a very good thing, isn't it? This is actually from plaster of Paris as well. No, it's solid. But the thing here is they made it into such a way that it solidifies that it can hold it and you don't expose it into water. All right, because it will dissolve. And what about this one here? What do we use sedimentary rocks for, guys? We use it for the glasses. Yes, the glasses here. The glass windows. Because glass windows are made of sandstone. Good. It is. It can be made of sandstone. The later version of metamorphic rocks, all right, will actually be, I forgot what's the name. It's not sandstone. It's a much more condensed form of sandstone. I can't remember it. I have to check up on it. Anyway, that's all for the sedimentary rocks. We move on to metamorphic rocks. Guys, just bear with me. It's only a few more slides, okay? Just bear with me. Shh. I know it's boring, but we have to get through the theory work, all right? This is the theory that you need to know because next week, what I'm planning here would be more of analysis of rocks, more of experiments to let you see what's going on, and that's about it. We just finish off the whole bulk of the theory section first, and after that, we'll do the practical. Lots of practicals that we're going to do next week, okay? Now, metamorphic rocks. Guys, can anyone tell me from the picture at the back here, what sort of characteristic can you see from these rocks? Yes?
It's really wavy and layered.
Wavy, layered. Yes, Christina?
It looks like it's just been all these minerals. It's not like sedimentary where it's like kind of smooth.
Yes,
All
kind.
like rocky.
Yeah, all like rocky. Good. Yes. What else can you see?
Shiny.
It's shiny. Yes, it's shiny. Yes. What else?
It's like normally like more colourful than all the other rocks.
Yes, that's right. That's correct. Now, why is that so? Why is it that it's like layered but it's a bit wavy? Because, guys, this is a new term that you have to take into consideration. When we come into metamorphic rocks, think about foliation. Foliation here is a term where it is a formation of layers or bands. But the layers is very different from the sedimentary layer where everything is very ordered. This here is actually due to intense heat and also extreme pressure. Now, guys, let's look at the front here when you've done copying. All right. Of course, you have, the crust that we have learned so far. And underneath the crust is actually the mantle. Now, of course, on the crust, you have volcanoes. All right. The volcano here that will erupt. Now, what's happening here is, guys, if I put Suraj on the top here and I push him to the bottom, all right, what will happen to him? Okay, he will definitely die. But why was that? What's the case? Why is that so? Sorry? No, who answered? I want to give the chance to the back. Suraj, why do you think that you will not survive? It's hot, yes? Rihanna? He will squish, yes? The pressure is actually the pressure. And what else? It's the heat as well as the temperature. So not only does the pressure, it's also just the heat. All right? Everything is being squished together and eventually Suraj won't be able to make it. But I'm just using it as an example just to wake you up, all right? So just put it this way. Because of the intense pressure and the heat, and guys, inside here, we are talking about what? 3,000 degrees Celsius, 4,000 degrees Celsius. I can't even survive 42 degrees and you ask me to survive for 3,000. No way. All right? So this is the reason why when it is formed, metamorphic rocks are formed inside the earth around the mantle is because of the heat and pressure. From sedimentary rocks, all right, once the sedimentary rocks are recycled into the metamorphic rocks, notice that this layering is actually from the sedimentary. They are all being squished together. All right, being squished together, they're being put under intense pressure, they're being pounded, they have been grinded, they have been baked. Everything all inside included. And that's when I call this a four-course meal. All right, intense pressure, heat, grinding, pounding. Everything will be included. Second point, third point here. But there is one good thing about this pounding and grinding. We have new minerals. Guys, let's look at this purple picture here. This is amethyst. All right, minerals. Amethyst. This is the beautiful collection that you can find in any stores. They just sell it. But it is actually made up of a metamorphic rock. But it is just that it is shinier, it's polished. Of course, it's obvious it's human made. But the fact here is, from the original material, it is actually unique on its own. What about this one here, guys? The one in the middle. Sorry? Ruby. Good point. Ruby here is actually extracted. And of course, for any girls, if you can get a ruby for your wedding, be happy. You got the right person. Ruby diamond, yes. That's why they say diamonds are a girl's best friend. All right? Now, what about this one here at the bottom? Shh, guys, yes.
Amber?
Not really much of amber. Could be amber as well, but it's actually, if I'm not mistaken, it's iron, but amber can be amber as well. Right? So, guys, remember these are all metamorphic rocks. Okay? Shh. I know you're all excited, but just calm down first. Now, this section here is a little bit more intense, all right? So what I would suggest to you guys, guys, listen up here. What I would suggest you to these guys is don't take so much of those words, all right? Only extract key points from here. You all right? Okay. Now, there are two types of metamorphism that we will come across. One is regional, and the other here is contact. But we'll talk about contact later. Sorry? No, you don't have to, because don't forget it's been recorded and I'll upload, the presentation up. But I just want you to take down key points. If you want to draw, if you insist drawing, leave some space, because these two will definitely have an interaction with one another. I'll explain to you on the board here right now. Let's go for regional metamorphism. When we talk about a region, what do we mean by a region? Can anyone give me that region definition? Yes, yes. It's an area, correct. And if we talk about regional metamorphism, it is actually a wide area, right? As compared to contact metamorphism, all right? It's a process that occurs over a wide area. So, guys, you think about a process, you think about occurring, and of course, this would be your keyword here, wide area. So, over a wide area, this is how you can do it. You don't have to write down sentence by sentence. You just need to pick the important points. All right? Caused by intense heat and pressure. You don't need to write this, because that's what happens in both contact and also regional metamorphism. So again, it is a repeated idea. I thought somebody fell down. All right. Second point. Remember we talked about the crust being the thinnest layer of the earth. This crust here can be broken down into what we call, larger sort of regions, but much bigger than continents, and that is what we call tectonic plates. All right? Tectonic plates. So these tectonic plates, guys, when you think of tectonic plates, what do you think of? Yes. Earthquake, what else? Yes. Tsunamis, yes. That's right. So basically those are tectonic plates, earthquakes, tsunamis, anything that you can see. Shh. Guys, calm down. All right. They are broken into tectonic plates and they move around the mantle. So from the crust, you have the mantle. Shh, guys, listen up. You have the region here. All right. You have the subduction, land masses colliding. You have the subduction of one of the earth. And what happens here is, remember, what process is actually happening in the mantle? What did I mention before? It starts with a C. You have learned in physics. Not crystallization. Crystallization is sediment. I'm talking about physics. Compression, yes, but there is one thing. It circulates. What is that particular word called? Convection. Good. All right. There is a series of convections that is going on in the mantle here. All right. They move around. This particular tectonic move doesn't mean that they go like to the disco and say, yeah, we're going to rock this earth. Yeah, we're going to rock. It is just only a movement, a slight movement. All right. So plates will collide. They will scrape past each other, heated up and compressed. So guys, tectonic plates, what happens here? Collide, scrape past, heated and compressed. Okay, guys? This is how you need to think about. Okay? This is what's happening in a regional metamorphic, all right? In regional metamorphic here, right? And if you notice, that is how mountains are formed as well, right? Due to the movement of the crust, mountains are formed. But what happens below here, we do not know, all right? Yes.
With the mountains, is it because the tectonic plates colliding and
Yes,
push up?
yes, they push it up. So they push up the rock to form the mountain. That's how it is formed. Okay? Shh, guys. Can I move on to the next slide? I'm going to move on. Wait, hang on. Next one. Don't worry, you can just check it, all right? As I said. All right. Sorry? Yeah, this is the next slide. Have a look here. We talked about regional before. Now let's go to contact. All right? Contact metamorphism, from the word itself, is actually in contact with hot magma. All right? In contact with hot magma here. And what happens? It pushes through the mantle and also the crust. Think about it this way. Because the lava here, the magma, I wouldn't say lava. Lava is actually the one that comes from the volcano. Magma. This magma here is in contact with that particular, metamorphic pressure, that intense heat and stuff. So what happens here is it will push its way through from the mantle to the crust, right? So it's going to push up here. Now, the difference between the regional and also the contact is only happening at particular small places. So you don't have to write particular local places on a smaller scale. You just have to write particular small places. All right, that's easy for you to understand. And the next one here is some rocks are actually from near the crust, which is true because we are trying to push whatever we have from the mantle to the crust. All right, and that is contact metamorphism. All right, and that is why, guys, sometimes if you look at the igneous rocks, for example, they will have some similarity with the metamorphic rock, is because of this particular process, contact metamorphism. Okay, so there is a reason why sometimes when you see igneous rocks, you say, Mr. Oh, this looks like a metamorphic rock. It's true, because guys, don't forget, everything is a cycle, everything is related. How you relate it is how you actually understand your facts well. Okay, now can I move on to the next slide? Okay, we'll just leave here. Okay, guys. Now, while you guys are just copying, I'm just going to ask the back. Any questions so far that you are not sure of, that you're not familiar with, or stuff like that? You're okay? You're quite okay? I think it's 9:30 already. Okay? Shh. Now, hang on. Shh. Guys, what I suggest is that every time when you revise, you don't revise the whole thing. You target some keywords and you have to understand, like sediments. Most of you are not sure what sediments are. So you target that word, you understand it, and that's how you define it. Okay? Okay, can I move on now? Yeah. Right, don't copy all the words. You only copy key points here. That's how you form your ideas. Right, don't worry, guys. What I'm going to do after this, you can just, have a look at it, all right? Okay. Now, wait, hang on. Don't need to copy further. I'm just going to let you talk about this. I'm going to talk about this. Okay? Shh, don't talk about this yet. Now, I just want you guys to understand. Metamorphic is actually a meaning. Shh. Metamorphic here actually means a change that occurs, all right? And what do we see in the changes here? Guys, shh. Do you see recrystallization? Do you see foliation? You have actually heard about these words before, so you don't have to really copy it, although you have the green arrow here. But what I'm just trying to say here is the changes that you see in the rock is actually recrystallization, which is new crystals that grow on the rocks as soon as it cools down. And the next is foliation. Now, foliation is actually the bending of those, sedimentary layers into a much more intense form. All right, and this depends on the amount of heat and pressure. So, guys, really looking at this, you don't have to actually copy everything, but you can check my slides after this just to make sure you're on the right track. Okay. Now, just think about this, guys. Shh. Sedimentary rocks is just like a book. All right, you have layers of pages of it. But if you throw water inside, all right, what happens to the pages here? Yes, it becomes wavy, it becomes crumbled. So think about it. Your book is a sedimentary rock type, is an analogy. Once you throw in water, heat, and pressure, it becomes wavy. Mirat, pay attention. Xavier, pay attention. All right? So you don't really have to copy everything here. You just have to really understand. Okay? I'm going to move on. Examples like this. Ah, thank God you don't have to copy anymore, which is true. You have, oh, I know. Guys, can you guys pay attention, please? Diamond, nice. Muscovite, hornfels, marble, quartzite. Marbles here are actually from limestone, guys. So it's actually a much more refined form of limestone. Limestone is rough and choppy. Marble here is eloquent. Shh. Next one. Uses of metamorphic rocks. I don't have to say ruby diamonds, amethyst, and here we actually use some of this as marbles. Marbles can be used as decorations. Okay? This is how it is. You can use marbles for decorations, but sometimes we tend to avoid it because marbles can actually dissolve when you have acid rain. All right? But it's only just for mere decoration purposes. It can be also made into statues as well. Yes. Definitely, marbles are used inside more than the outside, which is very true. Okay, the question, not the question, the statement here is marbles we can find it more on the floor in the house rather than outside. And also, if you have a marble floor, you tend to be a little bit more cooling. Yes. Yes. On the outside there, if they can last the weather, is more of plastic. But sometimes what they tend to do, when you have chemistry involved, you can actually coat the rock to make sure it doesn't dissolve. All right. So I think that's the way. But is it bluestone you're talking about? I can search up for it. I can just check and see, and I'll give you the answer. Okay. No worries. But again, guys, anything can happen with rocks. Okay. Anyway, that's all. Thank God for that. Okay. Next lesson, we will talk about the rock cycle, how it actually works. All right, and that's going to be a very short lesson. And after that, we'll do a little bit more experiments and stuff to actually see how sediment layers occur. We will talk about how we can simulate weather on particular stones, and that's about it. All right, thank you so much.